This video is our second of two videos of the PROG140 Chapter 6, and we finished up the first video starting to talk about common table expressions, or CTEs. And CTEs are a way to simplify complex joins and subqueries, and a means to query hierarchical data, such as an org chart. So the example here shows you the syntax. You start the CTE with the syntax of with, and then you give it the first derived table a name, and then you use the word as, and then parentheses, and then your code. So this code here is creating a derived table, a temporary table, if you will, that is going to find all the sum of invoices by state by vendor. The overall goal of this query is we're going to want to find the top vendor in each state, and then the maximum invoices or sum of invoices in that state. Something like that. We'll see. Anyway, so actually I could execute this first piece of code and it should work. And it does. So I get 34 rows. So it's by state, by vendor. I've got, multiple vendors in California, and this is the sum of all of their invoices, all the bills that they've sent us. Okay. Now we want to find the maximum sum of invoices in each state. And so we're continuing this common table expression. And now we're going to find the maximum sum of invoices from that derived table we just created above here. So since this, we're looking at this table in this second part, this has to come after this one, because if we didn't execute this first part first and create this derived table called summary, we couldn't use it in this second part, and our derived table is going to be called top in state. So we create this first derived table called summary up here, and then we use it down here to find the maximum sum of invoices by state. And I can't execute this by itself because the summary table doesn't exist unless I'm executing this whole piece of code. So now I want to find the vendors with the highest sum of invoices by state. And we're going to use the first derived table we created, and then we're going to join it on the second derived table to come up with the list of vendors top with the most invoices in each state. Let's see what that looks like. And we got 10 rows, since we have only 10 states in our database. And Wells Fargo Bank is the largest sum of the invoices in California, and Digital Dream something is the largest in California, something like that. Okay. You could do the same query without a CTE, but it's kind of hard to read. So it'll provide you the same output, but more challenging to read. So why do you need CTEs? Well, there are multiple reasons. So you could say that they're useful. Readability, we just showed you that. They can promote readability rather than lump all of your query logic into one large query. Create several CTEs, which are then combined later in the statement. This lets you get the chunks of data you need and combine them in a final select. You can use them as a substitute for a view, which we're going to cover views later in this course. But if you don't have permissions to create a view, which is an object, or you don't want to create one, as it is only used, in this one query, then this is a good approach. Recursion. You can use CTEs to create recursive queries, that is, queries that call themselves. Now this is handy when you need to work on a hierarchical data, such as org charts. We're going to see that, an example of that in just a moment. And you can overcome some limitations of some select statements, and you can use some ranking capabilities also. So a recursive query is a query that is able to loop through a result set and perform processing to return a final result set. A recursive common table expression must contain at least two query definitions, an anchor member and a recursive member. And these members must be connected by the union all operator. So this example is a recursive CTE that returns hierarchical data. So let's take a look at all the employees in the employees table. And I have 9 employees. This first employee, ID 1, Cindy Smith, does not have a manager, which indicates that she's the head of this org chart. And then Elmer Jones reports to Cindy Smith, and Paolo Locario also reports to Cindy Smith, but Ralph Simonian reports to Elmer Jones. So we only have a few columns in this table, but you actually can process a bunch of hierarchical information. Nice thing about this is there's no limit to how deep that hierarchy can go. So we're going to create an employees CTE, common table expression, and our anchor member is going to be employee ID, first name, last name as employee name, and we're just going to put a literal in here, one as rank, and we're going to put just one record in here to start, and that's going to be Cindy Smith because her manager ID is null. So then we join these with a union all. Union all includes duplicates. And this second part is our recursive member. So on the first pass, it gets employees with employee 1 as the manager. And on the second pass, it's going to get employees with employee 2 as the manager. And it processes until it finishes. And it's going to keep incrementing on rank. And the reason why it keeps looping is because we're joining on that table, that derived table that we just created in the code up above. So this is kind of cool. I mean, you might make a mental note to yourself if you need to process some hierarchies. Here's an example of it right in this code. So let's go ahead and run this complete CTE and see what we end up with. So Cindy is at the top of the hierarchy, and Elmer and Paolo are at the second level, and Ralph and Olivia and Thomas and Ria are at the next level. So you can see how this works. Kind of neat, really. One thing to keep in mind about these CTEs is that you can't execute them like individually. You got to do the whole thing, and it only exists while you executed it. It's not existing anywhere else in the database. You can't call it. You can execute this code again, but it doesn't create any objects. So it's just like real-time execution of code. Hopefully that makes sense. So let's see if there's anything else to talk about in this chapter. There isn't. So that's it for chapter 6.